Hello everyone, welcome to the solution of LeetCode problem 80 named Remove Duplicate from Sorted Array 2. In this problem, we are given an input array in an increasing order. We have to keep all of the unique element of the array at most 2 times. If any element appear more than 2 times, then we have to discard the element from the array. And we have to insert all of the resulting element from the start positions. Suppose in the example 2, the array has 9 elements, which is 0, 0, 1, 1, 1, 1, 2, 3, and 3. Now here, 2 appears 2 times. So according to the problem statement, we can keep 2 times because we can keep the element at most 2 times for the same element. Now here, 1 appears 4 times, but we can keep only 2 times. So we will keep 2, 1 here. And 2 appear 1 times, so we can keep this single 2. And 3 appear 2 times, so we can keep these 2 3s. After that, we have to return the total number of elements we have inserted in our resulting array. So here, we have inserted total 7 elements, which is 0, 0, 1, 1, 2, 3, 3. So in this case, we have to return 7. So here, the problem is we are given an input array in a non-decreasing order, and we have to remove the duplicate such that each unique element appears at most 2 times. The relative order of the elements should keep the same. I hope you understood the problem statement. Now the constraint are here. The array length can be in between 1, 2, 3 into 10 to the power 4, and each of the array element can be in between minus 10 to the power 4 to plus 10 to the power 4. And the array is given in a non-decreasing order or in an increasing order. I hope you understood the problem statement as well as the constraint. Now let's move on to the algorithm. This problem can be solved using 2 pointers mechanism. Here, we have taken the second example. It has 9 elements, which is 0, 0, 1, 1, 1, 1, 2, 3, and 3. Now, we have to keep the unique element at most 2 times. So here, 2 appears 2 times, so we can keep them. 1 appears 4 times, but we can keep at most 2, 1 here. And 2 appear 1 times, so we can keep this single 2. And 3 appear 2 times, so we can keep this 2 3s. So finally, this array will become 0, 0, 1, 1, 2, 3, and 3. So here, there are 7 elements modified. So we can say that in this problem, we have to return 7, and we have modified the input array. This is the brief explanation of the problem. Now let's see how can we solve this problem by using the 2 pointers mechanism. In this algorithm, we have taken 2 pointers. At first, our first pointer j is pointing to the second element, and we have taken another pointer I, which is basically a loop which will iterate through the every element from the second element. And the algorithm is, for each element I, we have to check whether the value of j is equal to 1 or not, or the value of a of I is not equal to the value of a of j minus 2 or not. If it is, then we have to put a of I into a of j and increase the value of j. This is the plain algorithm. This seems might be difficult right now, but I will explain it here. Now, currently our j is pointing to the second index. So the value presented is 0 in the jth index. And currently our I is pointing to the second index as well. So here we have to check whether the value of j is 1 or not. Yes, the value of j is 1. So one condition met here. So we have to put a of I to a of j. So here the value of a of I is 0. So we have to put 0 here. Now, after putting 0 here, we have to upgrade our j pointer. So currently our j is pointing to this element, and our current I is pointing to this element. Now, the value of the a of I is 1, and the value of a of j minus 2, that means j is here, so j minus 2 is here, and the value of j minus 2 is 0, and both of them are not equal. So we can put the value of a of I to a of j. That means we can put 1 here. Now similarly, if our I is pointing to this element, before that, as we have assigned 1 here, so we have to upgrade our j pointer. Now our j will pointing through this element. So here we can see that the value a of I is 1, and the value a of j minus 2 is this, which is 0. So 1 and 0, both of them are not equal. So here we have to assign 1 here. And as we assigned 1 here, so we have to upgrade our j pointer, and our j is pointing to this element. Now our I is here, but wait, if current I is pointing to this element, then the value of j minus 2, which is this element, which is also 1, and the value presented in the a of I is also 1. So both of them are equal. So here we cannot put any other 1 here. So it is not possible. So by using this algorithm, we will check that the previous 2 element is equal. So we cannot put the third one here. So here we will simply ignore this. Now our I is pointing to this element. Again the value is 1, and the value of j minus 2 is also 1. So here we cannot do anything here. So we have to skip it. Now our j is pointing to this element, and so here the value a of j minus 2 is 1, but the value a of I is 2. So both of them are not equal. So we can put 2 in the jth index. So as we put 2 here, we have to upgrade our j pointer into this element. Now our current I is pointing to this element 3, which is not equal to the 5 minus 3 or the j minus 2 element, which is 1. So we can put 3 here and upgrade our j pointer. So currently our j is pointing to this element. Now our current I is pointing to the last element 3, which is not equal to the j minus 2. That means 6 minus 2, which is fourth element, which is 2. So here we can say that 3 is not equal to 2. So we can put 3 in the jth index. After that, we have to increment our j pointer. So here currently our j is pointing to this element 7, and our I will become out of bound. So here we can see that the final output will be 0, 0, 1, 1, 2, 3, and 3. And the value of j is 7 right now. So here, this is the modified array, and we have to print the value of j, which is 7. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named remove duplicates, and the value of j is 1. And for each of the element from I to the last element of the input array, we will check whether the value of j is 1 or not, or the value of a of I is not equal to the value of a of j minus 2 or not. If any of the element is true, that means we have to assign the value of a of I into the value of a of j and upgrade our j pointer. Finally, we have to return j. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate the entire given input array. So here, if the size of the array is n, so in the worst case, time complexity is big O of n. And the space complexity is big O of 1 because we are using only constant extra memories to solve this problem. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.